Hi guys, we'll start. So I'm Boris. I'm going to present you the work done for the Maturity Assessment task force. I'll quickly introduce the context. The PolarSys Working Group aims to provide a complete toolset for the development of embedded software for the industry. So which means that it will be used by thousands of people around the world, and there is money at stake. So at some point we need to assess the maturity of this tool. This is how we are doing it. During this presentation, so the first section will state our objectives, say a little bit about PolarSys. Gail will do that. Then we are dealing with quality. So one of the first things we will do is defining what quality is for us. Then we will use metrics to assess the quality and the maturity of the project. So we will talk a little bit about what metrics we get and how do we get them. And we will demonstrate the proof of concept that we developed. And finally, we'll give the next few steps that are for the projects. So, Gael.
Okay. Okay, so I will just, So I will just spend a few minutes to tell you about what we do in PolarSys. So the idea behind PolarSys is really to create this user-centric community. So I think that Eclipse, we will agree that Eclipse is a business-friendly open source ecosystem. I mean that we have an open source community, but we have also 220 members, which are companies working, contributing, using Eclipse projects. And in PolarSys, we are bringing some large users like Airbus, like Thales, Ericsson, and so on. Large users on board, and really, this is what some people call super communities. It's open source communities that focus on bringing open source tools to new domains like embedded systems in our context. Where is the next slide? Okay. So the PolarSys Working Group, it's all about open source tools for embedded systems, and it's the goal is really to create new tools for model-based system engineering and addressing all the steps of system engineering and software engineering for embedded systems. To address the specificities of software tools for critical systems, of course. Why do we want those tools in open source? Is mainly because of interoperability, and those 2 points are really key points in our working groups. That's quality and maturity assessment, because more or less our members want to get open source tools that can be good alternatives to some proprietary tools they use, and they want to reach some level of maturity and quality that is sometimes find in the proprietary tools. Also, the very long-term support is the idea that we use open source tools to create embedded systems for space applications like satellites, or aircraft or telecommunication infrastructure, and those embedded systems are used by have a life cycle of 20 to 30 to 40 years sometimes. And we know that open source is the only legal framework to ensure that you can have tools supported for more than 10 years, for example. And that's typically what we implement. But let's come back to the maturity assessment. I think that it's a very important service we are implementing in PolarSys, and that's the topic of today.
Okay, as for our objectives for this work, so the first one is to assess the maturity of each component of the product delivered, because the full product as a stack of components is as strong as its weakest part. So that's the first goal of this project. But the second goal, which is at least as important as the first one, is to help people improve the maturity of their projects, which means help them understand and manage their project, provide them with guidance as for the good practices, and do things the Eclipse way. And another thing which is really important to us is to involve people in the definition of the maturity of the quality model and the maturity assessment, because as you will see, quality is a tough subject, and we really want to make it a constructive thing, so people can really use it to improve their practices and the practices of the project and so on. And what we do not want, metrics can be counterproductive sometimes, so we really want to avoid that. We don't want to judge or blame projects or people, and we don't want to address individual characteristics, because that's not our goal, definitely. So let's talk about quality. The problem when you talk about quality, if you ask what quality is for, what quality is to 10 different people, you will have 10 different answers. And none of them is wrong, and none of them is true. So there are a lot of usual definitions for quality. There are a lot of standards and norms. And the point is that none of them is absolutely okay for us. So we will rely on them. As we will see, we will rely on the ISO 9126, on the CMMI, and on other quality models, especially for the open source. So we will build upon them. The fact that we are open source has an impact on the quality model, because we will want to measure also the community, the activity of the community, and things like that. So we have to design our own quality model. So the first thing we did was to gather the quality requirements for us. And so first for Eclipse, which is an open source foundation and so on, and more specifically for PolarSys. And what we found was 3 main characteristics, which are the process, the ecosystem, and the products. For the process, we have things like we want predictable outputs, we want a well-defined structure for the projects. For the ecosystem, so the Eclipse way of life say that you have 3 communities, you have to nurture them, you need to have a good citizenship behavior. And as for the products, which is quite more common, we need to be maintainable, so which is true for every open source project. We need to be reliable, and we want to enforce good practices. So here is how we organized all these quality attributes. If we want to look at each of them, for the ecosystem, we have the activity of the community. Are there a lot of commands and commits and mails on the mailing list and things like that? The diversity, are there a lot of people working on the project, or is there only one person working on the project? Responsiveness, if you ask a question, how long does it take to have the answer? The support, what is the amount of knowledge that you get when you ask an answer? The visibility, the usage, the user feedback, what users think of the project. As for the process part, so you can recognize some of the key process areas of the CMMI. You have configuration management, change management, intellectual property management, which is quite important for Eclipse, and planning management and test management. And for the product, so we have 3 characteristics which are true for all open source projects. So they are analyzability, changeability, and reusability. And in the context of an industrial solution, we also wanted to add the reliability. Another problem we have with such a project is that we want to measure very different types of projects. As an example, we will be measuring Java projects, which are object-oriented, but also C projects, which are not. So for that, and some projects may use some tools and some not, so we may have missing values. What we did for that is to define the 3 phases in the quality model. So first we have the quality attributes. So as we have seen, they define what quality is for us. The second phase is our measurement goals. So there are kind of generic units of measurement that can be applied to all types of projects. And they are mapped to some base metrics, which are the real numbers we get from the process and from the product and so on. And they are project specific. One example, as a measurement goals, we may have the complexity of a product. Okay, in some cases, we want to measure the cyclomatic number for the complexity. But for an object-oriented project, then we would like to add some measures about the depth of inheritance tree or things like that. So we may have different metrics for the same measurement goal, which means that we can measure projects with a different structure and using different tools and with different languages with the same quality model. And here it is. So on the left, you have all the quality attributes that we have seen. They are mapped to some measurement concepts, measurement goals. And then you have one or more metrics which will allow to compute the measurement goals and then compute the quality attributes. Okay, so now we know what we want to measure, so what is important to us, what are our concerns. And we need to gather some metrics to compute that. So this is called mining software repositories, and we are addressing a lot of different areas of the development process. First, we are gathering information from the source code through SonarQube for the pure code metrics, and also some rule checking tools like PMD and Findbugs. We also are gathering information from the process with the configuration management, issue tracking system, mailing lists. That is done through the Grimoire open source tool, which is behind the Eclipse Dashboard. The guys here are working on this project. We also are working with the PMI project management infrastructure project from the Eclipse Foundation. We'll talk about this a little bit later. And what we could do as well, which is not yet the case, but what we could do as well is analyze the forums, analyze the websites, and even have manual surveys and so on. So we can have a great diversity in the metrics that we gather. Okay, as for the source code, so as I said, most of the metrics are retrieved from SonarQube, but we may as well use different tools. So if we want more metrics or if we want to replace some metrics, we can just easily plug a new tool to get the source code metrics. What we can say about the metrics is that we tried as much as possible to make them relative, because you cannot compare a small project and a big project. The number of commits will be different and the complexity will be different, and that's just normal. So what we do is as much as possible, we do ratio. One example is the comment rate, so it's a percentage of lines of code. You have the complexity density, which is the cyclomatic number per function, or the duplicated lines density, which is the amount of duplicated line per thousands of lines of code. But of course, some metrics are kept absolute because they have a meaning when they are absolute. Examples are the source lines of code, which is the size of the product, and also the depth of inheritance tree, which would be pointless if we divide it by a number of lines of code. We also have rule checking tools that run. What is really interesting with them is that they provide good and bad practices as defined by the open source community. As an example, you have a getter, you have a setter, then why your attribute is public. So now we run only PMD and Findbugs, but we could very easily add the new rule checking tools. This one are for Java, but we could add tools for C, for .NET, I don't know what. So here are a few examples that we may add. Examples of metrics that we can get from that is the number of violations for the product. And more specifically, when we define one violation, then we say it impacts the analyzability or the reliability and so on, which means that we can say there are this number of violations that impact analyzability and so on. So we have the number of violations for each of the quality attributes. Another interesting metric is the number of acquired practices. That is, when a rule has never been violated in the product, then we can say that the project has acquired this practice. They never do that. So that's interesting as well. For software configuration management, we use the metadata from the tool. So that's Grimoire once again. The supported tools are Gate, Subversion, CVS, Bazaar, Mercurial. So there are a lot of tools that we can plug to. And examples of metric include the number of commits, number of committers, and number of files committed. We can have different time ranges if we want. The same for issue tracking system. So it's still Grimoire, and Bugzilla, Jira, Redmine, Launchpad, GitHub, and the SourceForge issue tracker are supported. And some examples of the metrics we gather are the number of bugs per 1,000 lines of code, number of active users on the ITS during last month or last 3 months, and so on. Number of updates. So an update is either a command when you change the status or whatever. And a time-related metric, which is the median time to fix issues during last month. As for the mailing list, so Grimoire will take as input mbox files. So we need the mboxes for the mailing list of the project, or also Gmail. And examples of metrics that we gather from there are the number of mails exchanged, number of threads, so one thread can have one or several mails, the number of active authors on a given period of time, and so the median ratio of answers on questions. So if I ask a question, globally how many answers I will get for my question. The PMI, so the project management infrastructure, so it's an Eclipse project, and it gathers a lot of information about the project. So you have information about the different repositories, so source code repositories, ITS, mailing lists. You have a lot of links for the documentation, so you have the website, wiki, getting started, some information about the build process, where the official documentation, so we can have a list of the different documents. And you also have a description of all the releases with the date, the scope, the status of the review, and so on. So that's the theory, and then how do we do that? This is the architecture of the prototype that we have developed. So on the left here you have the data sources. You have Grimoire with the configuration management, mailing list, issue tracker. You have SonarQube for all the code source related metrics, and we also have the rule checking tools here. From all of this we get one file, one big file with all the metrics inside, and from that file we can compute the quality model. We also have the definition of the quality model, so it's in a JSON file, so it's quite easy to modify it, to improve it, and so on. We have a description of all the metrics that we use. We have a description of all the rules and the concept that we use. So everything will be taken as input to a script, which is to publish the dashboard. And we will produce a HTML dashboard from that. We could also produce PDF reports and things like that. The point with the dashboard is we want it to be absolutely self-documented. So if you need any information, you just have to click on the link and you get the description of the metric, and you get the description of the rules or the practice, why it is important to follow the practice, and so on. Another thing is that the generation of the dashboard is, so we generate the dashboard from the Git repository. So each time we change, say, a metric, a value for a project or whatever, we run the dashboard and everything is up to date. So this is what it looks like. This is the home page of the dashboard. On the left, you have a menu. So the first thing is the documentation, because it's really important for people to understand what we are doing, so they can really get a lot of benefits from it. And then we have a few example projects that we selected as samples to demonstrate what we want. And generally, you have a box on the right which gives more information, allows to download the data and so on. When you click on the project, you arrive on this page, which is all the information we gather from the PMI file. So you have all the repositories, the mailing list, and the description of the releases and milestones and so on, which is here. This is important because you can download all the files that we generate, so the metrics, the attributes, the concept, and so on. So now it's only JSON, but we can produce CSV really easily. So if you want, you can take this data, the data is yours, and you can import it in your favorite spreadsheets, I don't know what, software. So you can plot things, visualize them, and do whatever you want with them. This is the quality model that we have already seen, but you will see, no, you won't see, but trust me, there are some numbers here. So we can already attach numbers to the different metrics, and we can have the concept, measurement concept here, and then we can have the quality attributes here with a notation on it. Every time if you need some information about a specific concept, then you just have to click on the node and you will have the description of the metric, attribute, concept, and so on. Then a few pages which give the numbers for the different attributes, the different measures, so for the base metrics, and the practices, with some nice graph. And every time that you click on a link here, you have the full description of the practice. So the rules have priority, and you can see here what quality attribute they impact, and you also have some nice visualization as well. This page is really nice because it's okay to say I have a bad notation on this part, and I know that the mailing list is not very active or things like that. So the action part gives you hints about what is the next good action to take if you want to improve your quality. So say there are some actions that are really heavy, so if I tell you to acquire this practice and you have thousands of violations, that it will take months. So the point here is to give just the next thing to do to improve a little bit the quality of your projects. Okay, so that's where we are right now, and what we should do in the next weeks and months is first set up scales. So what are scales? If I tell you that you have 200 commits a month, whoa, what does it mean? Is it high, low? For many people at least, this is useless almost. So what we want to do is to set up a 1 to 5 scale and say, so 200 commits a month, it's quite good, so it's quite high, so it means that you are quite active. Then it depends on the number of files on your project and so on. But you can apply it to every metric. But how do we do the thresholds? That's quite an open question. We would like some feedback about that. We're going to set up a panel of projects and then use statistical methods to say, okay, so compared to the others, so projects from Eclipse and from other forges as well, then it's quite high or it's quite low. It's not a judgment, it's just telling you how you compare to others projects. We would like also to improve the presentation of results, and so I'd like add more visualizations, improve the ergonomy. We'd like to add more content, so maybe there are some metrics that should be added. Say about the requirements, maybe more metrics about the tests. If there is a metric that you would like to add, then just tell us and we will consider it for the next iteration. We could add also new rules, especially for new languages, so for C maybe, or from tools that are specific for the security, I don't know. We have to improve the automation. The goal here is to set up something like a Hudson job, and if you want your project to be analyzed with this process, then you will only have to fill a few parameters, and then the whole thing would be automatic, and then you will get the assessment of your project. So that's not exactly the case right now, to be honest, but if you want to come into that, I can help you, and soon you will be able to do that by yourself. And finally, what we want, of course, is to add more projects to the panel. So the more projects we have, and the more consistent and rich is the analysis, because we can compare to others and get, so if I'm not good, say for the activity, then I can look at a project which is better than I am on this subject, and so on. So, and maybe if you have a project, we could add it, so please tell me. And that's all. If you want more information, there are a few things that you can see. So the first thing is the PolarSys wiki, and there is a page on the wiki. There are a lot of pages about maturity assessment on this wiki, but this is the main page, so Maturity Assessment WG. There are a lot of information as well on the PolarSys mailing list, so you can subscribe here, it's public. And the live demonstration of the prototype, that's still a prototype as of today, lives here. So that's the end. Thank you for your interest. Would you have any question about that? Okay, so thank you then.